So I want to welcome everybody to another session of the Forest Protection Forum. This series is put on by the Stop Clearcutting California campaign, which is a Sierra Club campaign. And with three things we do mainly is put on this forum, write letters to the editor and other comments, and post on social media. So today, a speaker, and Kristen's going to introduce our speaker, Bryant Baker, in a moment. Please put your questions you have during in the chat, and when he's done talking, we will ask the questions. And if I haven't muted you, please mute you so we can hear him and not, various people talking to their dog or whatever. Okay, so Kristen, you want to unmute yourself and.
Great. Well, thanks everybody for coming. Bryant Baker is here with us today, and he is the Director of Conservation and Research at Los Padres Forest Watch, a nonprofit organization based in Santa Barbara, California, which is dedicated to protecting the Los Padres National Forest and other public lands in the region. Bryant is also the director and principal GIS analyst at the Wildland Mapping Institute, which is focused on putting GIS to work for wildland research, education, and conservation. Bryant has co-authored several peer-reviewed papers on fire ecology and management in shrubland and forest ecosystems in California and the Western United States. Bryant's maps on land use, wildfire, and other conservation issues have been published by the Los Angeles Times, San Diego Tribune, OPB, that's Oregon Public Broadcasting, Montana Free Press, Mother Jones, and other outlets. In addition to his conservation work and research, Bryant is a plant and landscape photographer specializing in post-fire habitats and native plants in California. Bryant's work has appeared in books, magazines, and newspapers across the region. Welcome, Bryant. Take it away.
Great. Thanks, Kristen. Thanks for having me. I'm going to share my screen real quick, and everyone should see my presentation. Good. Okay. So, I'm Bryant Baker. Thanks for the introduction, Kristen. I am mainly here sort of as in my role at Los Padres Forest Watch, I think because it's so focused on the Southern California area and fires in this region. I've been doing this work for how many years now? Since 2016. So I've been based in the Santa Barbara Ventura area for the last nearly a decade. I've encountered many fires over that period. I'm going to talk about some of those fires that I've experienced, and also some fires that well predate me and predate all of you as well. So the main thing, though, I really want to convey with this is I want people to come away from this presentation with a better understanding about this ecosystem we call Chaparral, and what its relationship with wildfire is like. And what we can learn from some of the recent fires that we've been seeing in the Los Angeles area, for example. All right. So the title of my presentation, it refers to Chaparral as the Elfin forest. I'm actually not sure who first coined this term, but I love this name for Chaparral. And you can find this wonderful book from 1923 by Francis Foltz. He actually, leading up to to 1923, he was writing several articles mainly in the LA Times about how amazing Southern California is, and especially how Chaparral is. And I love this. He has this sort of intro in his book, and he's basically comparing Chaparral to giant sequoia forest, and he is trying to convince folks, like, Chaparral is actually really cool too. Everyone always thinks about the trees, but don't forget about the shrubs. A question, we talk about Chaparral a lot in California, and people use the term a lot, but I'm not sure that everyone fully understands what Chaparral is. And the sort of basic definition is that it is this ecosystem. It's this vegetation type that is composed. It's mostly shrubs. It's this shrubland ecosystem, and it occurs in this Mediterranean climate region that we have here in California, but also in Baja California, and parts of Oregon as well. And it makes up about 9% of the vegetation in California, but it is the most widely distributed ecosystem that we have. And so if you look at the area where chaparral tends to occur and where it can be dominant, it's a pretty large area. It's most well known in the on the central and south coast of California, in the transverse ranges and the peninsular ranges, and also the southern coast ranges. But it actually is quite common, sort of scattered up north of the San Francisco Bay Area, and all throughout the foothills of the western slope of the Sierra Nevada. So it is kind of all over the place. It actually also occurs in patches all throughout the Klamaths, mostly on serpentine soils. And so it comes in a lot of different shapes and sizes. And I can't really stress this enough, that chaparral can look very different from one place to another. But the sort of overarching connecting theme here is that it is a shrubland ecosystem. There's not really a lot of trees. It's pretty closed canopy typically. And it's not a very tall ecosystem. Sometimes you can find chaparral that is pretty pretty tall and has some big shrubs, but this is what you expect to see if you're walking around the chaparral. And again, I just want to reiterate that it comes in a lot of different shapes and sizes. It's not just brush. That's what a lot of people think of chaparral as, is it's just brush land. And there's a lot more to it than that. It actually has an incredible amount of biodiversity. And I think it's something like, it accounts for 9% of the vegetation in California, but it is home to 20% of our biodiversity in the state. So there's a disproportionate amount of biodiversity in this ecosystem. And there's a lot to love about it. And I think a lot of people just really associate it with fire, with, that it's brush. And I would love if, as a society, we could somehow move past that, although that still seems difficult these days. There are these two types of chaparral that I'm not going to really talk about today. Montane chaparral, that occurs in higher elevation areas. Like you'll find this in the Sierra Nevada, up at the higher elevations, sort of scattered among forest. And this is kind of its own unique thing. There's also a sort of related type of chaparral that we see after in the immediate years after high severity fire in certain forest types. You'll see that several shrub species will become dominant for a while until the conifers start to reestablish. I'm not really talking about those. I'm talking about the more traditional mixed chaparral, and also coastal sage scrub. I'm just sort of lumping that in with chaparral as well, but where it tends to be this climax community that is dominant across much of the landscape where it's found. That's really what I'm talking about. Okay, so what makes shrubs in chaparral special? How are they unique? That is, there are other shrublands on Earth. Probably most famously in North America would be the sagebrush ecosystems that we have in the interior West, the Intermountain West. But what we see in chaparral is that a lot of the shrub species, even though they're quite unrelated to each other. For example, these are three separate shrub species that are from three entirely different families. This chamise here is in the rose family, for example. This is in the buckthorn family, and this is in its own weird family that is sort of the silk tassel family. But they all have similar adaptations to our Mediterranean climate. They are adapted to these cool, wet winters, but these dry, long, dry, hot summers where we go many, many months without any rain, usually from something like May all the way to often November, or as we've seen this year, this past year, we really had no rain, not much at all until just within the last couple of days in Southern California. But you might notice that these plants, they may not, maybe chamise, it's kind of hard to tell how it's related, how it's similar to these two plants, but you'll notice that they have small leaves. They have a lot of leaves. Their leaves are not, they don't have a lot of surface area typically, and they have all sorts of unique ways of dealing with that high heat and dryness. It's all about conserving water. And so this is chamise. This is probably the most common of our native shrubs found in Chaparral, and probably the most common native shrub west of the Sierra Nevada. And it is really well adapted to these dry areas. And you can see the leaves here. They're almost like rosemary leaves. And rosemary you can think of as sort of an analogous species that you would find in the Mediterranean area, which is also, of course, in a Mediterranean climate. Now, the big topic always is what about fire? What is normal in Chaparral? What do we know about fire? Yeah, there's a lot of folks have a lot of thoughts about Chaparral and the fire regime, but it's actually pretty well established in the scientific literature what we know about the fire regime historically. I'm not sure it's exactly what you would call the natural fire regime, but it's definitely what has it's the historical fire regime, and this goes back to pre-colonization as well. It's not to say that small fires didn't occur or don't occur, but what we know from quite a bit of different evidence is that every now and then, usually once or so a century, a large area of Chaparral will burn in a wind-driven fire, usually like Santa Ana winds, for example, in Southern California. So we think of the fire rotation as of 30 to 100 plus years. Sometimes you'll see it talked about as 30 to 150 years. It's really hard to get that top range there, but we know that the 30 years is a pretty good low end of the range, because as you start getting below 30 years, Chaparral has a hard time persisting over a long period of time, and I'll talk more about that in a bit. The other thing that is really, really important to understand about Chaparral, there is really no such thing as like low severity, low intensity Chaparral fires. When Chaparral burns, it burns hot, it's intense. Everything after you'll look at an area that's mature Chaparral, immediately after the fire, it'll look like every single plant has been killed and charred. That is actually completely normal, and that's actually what you want to see with Chaparral because of the way a lot of these plants deal with fire. That's what they're used to, basically, is that type of high intensity crown fire regime. And I'll talk more about that here in just a bit. So how do we know that large fires have been occurring on the landscape in, say, Southern California, where Chaparral is dominant? How do we know that that's been going on for a long time? There's this famous study from 1999 where some researchers looked at sediment in the Santa Barbara Channel here. And what they were looking for was charcoal accumulation in these sediment cores. And you can see this is a really good example of where you might be getting charcoal, accumulating in the Santa Barbara Channel. It's from these Santa Ana wind-driven fires. This was in 2017. This is satellite imagery. You're seeing the Thomas fire there, blowing smoke, lots and lots of smoke out over the Santa Barbara Channel. I'm not going to go into the details of how they did the study, but the basic gist of it is, for about 100 years of their data, the sediment data, we knew where large fires had burned on the landscape. And so what they were able to do was they were able to match these sort of peaks in the charcoal, these charcoal layers. They were finding there was more charcoal in the years where there were these large 50,000 plus acre fires somewhere on this landscape, where fires could be blowing smoke out over the Santa Barbara Channel. So it's really this whole sort of region right here. And what they found was that over the last 560 years, these large 50,000 acre plus fires were occurring somewhere on the landscape once every 20 years or so, and that was remarkably constant up until about 2000. So what does that mean? That means that regardless of whether it was pre or post colonization, whether it was the sort of Mexican colonization era, or the Spanish and the Mexican era, or the American era starting in the 1800s, it didn't really matter. What they were finding was that these big wind-driven events were sort of inevitable on the landscape. And that's a really key finding. So every single one of these arrows, if you're looking, we're going all the way back to before 1450, every single one of these arrows is a large 58,000 acre fire. Again, that does not mean the same exact spot is burning every 20 years. It just meant that somewhere on this large landscape, there was a big fire happening once every couple of decades. So we know that. Another study that came out about 10 years later, they used fire scar. They were looking at tree rings. They were looking for fire scars and tree rings of this really interesting species called bighorn Douglas fir that's endemic to Southern California. You can only find it from Santa Barbara County down to Baja California. And what's interesting about this species is it forms these really these lovely stands, these bighorn Douglas fir stands, where they're the dominant species, and they tend to be surrounded by chaparral. And so they're kind of a relictual species. These populations have sort of held on since the Pleistocene, since the climate was much cooler during the last glacial maximum. They were probably much more extensive during glacial maxima. But these little remnant populations, they actually can give us some insight into the last several hundred years of fire activity in this area. And what they found was that they looked at a bunch of different stands in the Los Padres National Forest, and ultimately what they concluded was that their results were lining up pretty nicely with that study that looked at charcoal sediment in the Santa Barbara Channel, and that they concluded, as in recent decades, past widespread fires were likely driven by extreme winds and drought conditions. So again, these big, intense fires in these chaparral-dominated areas, especially in Southern California, they have been occurring for a long time, and they continue to occur. And if you're curious, it's really hard for folks, especially folks that just moved to maybe to Southern California, and they experienced their first big fire, and maybe it burns in a place that they're very familiar with because they've been hiking there for a couple of years or something. It can be quite shocking to see the immediate post-fire chaparral landscape. And I'm going to show you some modern images, and they're going to look identical to what you see here. These two photos, it's hard to tell that these are photos, just the quality is not great, but they're from that book, The Elfin Forest, from 1923. So these are from the early 1900s in the mountains around Los Angeles. And you can see just sort of, it almost looks like a barren landscape with some charred stumps and charred stems sticking out of the ground. That is the norm, and you will be amazed at the transformation that it goes through. So I've done a lot of work in areas that have burned in chaparral, trying to document the regrowth process in a way that I can convey to the general public to get folks to understand what to expect over the next several years. Because a lot of people just feel hopeless about an area burning. And there are caveats to this, but chaparral is pretty well poised to make a comeback after these fires. There is a big caveat to that, but I'll talk about that here in a bit. So this is an area above Santa Barbara, and it's an area I was quite familiar with. And in 2019, this exact same area that you see in this photo, everything you see burned in a fire called the Cave Fire. And this is what it looked. This is just down the slope from where I took that photo. And this is what it looked like after the fire. Every single part of the landscape looked like this. And it's kind of shocking. This was about a month after the fire. And most people that go and see this, they don't have like high hopes for this area. But I want to show you what it did over just a short 17-month period. As I went out there, it goes through these wonderful phases of transformation. This was really fascinating, where you had all of this wild cucumber, this native vine that is common in the chaparral. You often see it draping over shrubs. It's a native plant. It's really amazing. It has these massive tubers that are deep underground that just aren't affected by fire. And so after, in the immediate sort of early part of the growing season after a fire, usually you'll see the wild cucumber take off because it has nothing to compete with it for sunlight. After that, you start to get some fire following plants like morning glory and phacelias. Eventually you'll notice that a lot of the shrubs are able to resprout. A lot will come up from seed, and it starts to get back on a trajectory where, you can see, oh, okay, maybe in like 10 or so years, this is going to look sort of similar to what I remember from before the fire. This is another area that burned in the same fire. Again, this is 1 month after the fire. It just looks like surely nothing will ever grow here again, right? Not only will things grow there again, most of what you just saw, those stems actually survive. All these stems, for the most part, survived the fire. So these are resprouts that you're seeing here. A lot of different shrub species that are resprouting. And then we have all sorts of growth in between those, growth from seed. So how do plants do this? Like, what's going on in Chaparral? And this is not necessarily just limited to Chaparral. There are these plants that fall into these groups in other ecosystems. But when we talk about Chaparral and fire, we usually talk about these three big categories of how plants cope with fire. How do they persist their population? So there's the obligate cedars. These are a lot of examples of these species are in the Ceanothus genus and the Manzanita genus, Arctostaphylos. So most of the mature individuals, they die in the fire. Like, their population is usually completely wiped out in the fire. But they have this massive dormant seed bank that is stimulated by all sorts of different fire cues. With Ceanothus, for example, that's actually what you're seeing here. This is a species called hoary-leaved Ceanothus, and that is the remnants of a mature individual that died. Notice that it's not resprouting, but it has lots of little seedlings that are coming up, and those are actually coming up because they germinated in response to their germination success is greatly enhanced by high heat. So essentially, a lot of these seeds, they have like a pore on their seed coat, and it's got this like really tough, waxy, plug. Think of it like that. I'm trying to really simplify this, but the heat gets rid of that and allows water to get into the seed coat, get through the seed coat and into the seed. And that's when germination occurs, right? So the fire doesn't necessarily literally cause germination. It just makes it so the seed is ready to germinate once it receives water after the fire. Hope that makes sense. So that's what you're seeing here. Now, again, cannot resprout. The only time, for the most part, that you see a bunch of recruitment into the population is all within the first few years after a fire. You see all of these seedlings come up, and that is what establishes the population that will probably be there until the next fire comes, okay? Now, there are facultative cedars. Those are plants that they also go through a lot of the same processes when it comes to seeds and germination and having big dormant seed banks that are their germination rates are enhanced by these fire cues, but they're also able to resprout. Chamise is a great example of that. You can see it here. This is chamise resprouting just a few months after a fire. And then these little guys here, those are all chamise seedlings coming up. And so those were very probably seeds from this individual plant itself. And then there are the obligate resprouters. These are the plants that are sort of the opposite of our cedars, right? They're the ones that they don't have long-lived seeds. They don't have dormant seed banks. They aren't usually wiped out. Their population isn't wiped out when a fire occurs. Their mature individuals usually survive and resprout. And their seeds only usually grow to maturity in those long fire-free intervals, right? Those periods between fires. Okay, so the vast majority of plants in the Chaparral fall into one of these three categories. And this is cool. This is some drone footage, a drone photo that I took of this area that I'd been documenting for, at this point, a couple of years after a fire. And you can see a lot of this playing out. So there's this whole little area over here where the soil is pretty dry. It's kind of a poor soil compared to this area. And that's where chamise was pretty dominant before the fire. And then you can see a ton of resprouts. So there's a lot of resprouting chamise over here. There's also some resprouting manzanita that's harder to see here. So that's your facultative cedars. There's also little seedlings growing there as well. And then you've got your obligate cedars. The big pod ceanothus, for example, you can see it's this kind of lighter green color, and it's really filling in all that interstitial space between these other shrubs that resprouted. So lots and lots of new ceanothus growth coming up from seed. That's an entirely new population that's forming there. And then there's another facultative cedar, the greenbark ceanothus, in the same genus as big pod ceanothus, but it is able to resprout as well. So that yellowish color there, those are resprouting greenbark ceanothus. And we also have some obligate resprouters like the interior live oak stand up here, hollyleaf cherry, the toyon. You'd be hard pressed to find individuals from these groups that were mature before the fire and were outright killed and didn't resprout after the fire. Most of them resprout, and you can really see the toyon because they were fruiting when I took this photo. So there's a bunch of them all through here. Now, the other group that I'm not going to really get into too much, but this is another one that's important to know, are the fire followers. These are usually plants that we think of as endemic in a temporal sense. You tend to only see them on the landscape immediately after a fire, so for the first few years. And so this is the same exact image, but you're seeing it at 1 week on this half and at 5 months after the fire on this half. And so you look at just in that first 5 months of growth, it's pretty amazing how well these Phacelia, this is giant flowered Phacelia, established. This is a species that you really do not see in any significant numbers, except for in burn areas in the first few years after a fire. If I went back up there today, this is a photo from 2020. If I went back up there today and took the same shot, I wouldn't be able to take the same shot because I'd have to bushwhack, and that's just too much work because there's so much resprouting shrubs and there's so much growth here. It'd be hard to get to this exact spot again. But I can guarantee you there would be few, if any, of these Phacelias left because they only persist for a few years after the fire while there's a lot of sunlight and there's not a lot of competition from other shrubs and things that are shading them out. But they're really important from a biodiversity standpoint. They're really good at bringing pollinators back into these burn areas. And of course, they're attracting insects. The insects are attracting birds. Birds are attracting other birds. Birds are attracting bobcats. There's a whole food web here that is really enlivened by these fire followers in the immediate post-fire period. This is not necessarily exclusive to fire followers. A lot of these are fire followers, but this is just to give you a sense of how beautiful these post-fire areas are. These, I think, all came from like the same post-fire area, the one I was just showing you that I documented for several years. These are all plants that I documented within the burn area after the fire over the course of a couple of years. And it's just really amazing to see all of this growth and all of this beauty in these areas when, again, right after the fire, like right now, if you were to look up at the hills in the Santa Monica Mountains, it's as bad as it will look probably ever. And then, given time, it will start to reestablish and this beauty kind of comes back to the area. Now that you understand the different strategies that plants have for dealing with fire in Chaparral, you can start to understand why fire frequency is a very important topic when we talk about this ecosystem. Some species, particularly species that are obligate cedars, remember the ones that can't resprout, these are the ones that they have this big dormant seed bank. Their population gets wiped out during the fire. They then grow their new population from seed. They need time after a fire to grow to maturity and then to start accumulating seed in the soil so that they can prep that seed bank so that it's ready the next time a fire comes through. There are some species that need quite a while to get their seed banks up to something sufficient to basically reestablish the same number of individuals as the previous population. That's what this study found from 2002. they were looking at this really cool Manzanita, Arctostaphylos moroensis. This is up in Montaña de Oro State Park in San Luis Obispo County. This is a Manzanita that is an obligate cedar. Its seeds really respond, I think, to a mixture of heat and smoke, chemicals from smoke and charred wood, things like that. But they found that this area that had burned 40 years prior, they then did a prescribed fire on that same area. Again, a prescribed fire in Chaparral, any fire in Chaparral, if it actually burns things, it's going to burn most of the vegetation, and it's going to look kind of like what I showed previously, that photo, right after a fire. That's true for a prescribed fire and for a wildfire. So they then were looking at how many viable seeds were left and how many were germinating and what the germination, the success rate and the mortality rate. They were looking at all these things, and they found that even though these plants had 40 years to build up a seed bank, that it still wasn't quite enough to create a seed bank that was resilient enough so that their population could reestablish at the same numbers during the next fire, right? So some species need several decades to grow to maturity. That's really important. And there are a lot of species that fall into the category of obligate cedars and need quite a bit of time. This is an area that burned in the Thomas Fire in Santa Barbara County, this little patch right here. What was interesting about it was that this whole area had also burned, when was this? In 2009. So this photo was in 2021. So a fire burned in 2017, and it reburned an area that had burned in 2009. Right. So we're talking 8 years between fires. And then I came out 3 years later, and I could not find a single seedling of all of these stems you see. They're mostly this species called big pod ceanothus that is very common. It's a very prominent member of the Chaparral community in this area. No seedlings whatsoever in this area, even though we're talking 3 years post-fire. And again, it's because all of these big pod ceanothus that had come up after the 2009 fire had not even gotten to maturity yet to even start producing seed. They need time between fires, or else you start to see these types of species disappear from the ecosystem. And this is something that has been pretty well documented across Southern California, especially in the Santa Monica Mountains and in the San Diego County area. Chaparral, under normal fire frequency in the Santa Monica Mountains, this is what it looks like. And this was an area that had burned 3 times in just 12 years. And so what you see in the foreground here is this invasive grass called wild oats. And that is what is blanketing the slopes here in between some of those shrubs that can resprout. So some shrubs can deal with that higher frequency of fire because they can just resprout. Even they have problems with resprouting so quickly after one fire. It's kind of an intensive process to resprout and sort of redevelop yourself as an organism, as a plant. But those plants that were only coming up from seed after the fire, those can easily get wiped out. Those species, and what usually comes into their place are these invasive grasses and weeds like wild oats or black mustard, for example. And so this is what we call type conversion, where this has gone from chaparral to something more like a grassland, almost like a chaparral savanna. And it's not really what we want to see here, mainly because it is dominated by non-native grasses and weeds. If it was native, herbaceous species, that would be a little bit of a different story. But I think the takeaway here is that the real issue is that when we lose chaparral, we see this trajectory that these places get on, and they're moving toward being dominated by non-native grasses and weeds. And we can see this in lots of areas, and I don't want to get too deep in the weeds, so to speak, here. One of the things that comes up a lot with chaparral is people will talk about, well, we need to keep the chaparral young. We don't want to have any mature chaparral out there because it's a much greater fire risk, if we have old growth or mature chaparral. What we find is that fires often, especially fires that are driven by extreme winds, they burn through areas that had recently burned within the last decade or the last couple of decades. So we see this a lot. And so this is an area in Santa Barbara County, along the coast near Santa Barbara, 36% of the area that burned was old growth chaparral. The rest was either grassland or ag land, or a lot of it was young growth chaparral that had only been growing for about a decade or 6 to 17 years after the fire, after two previous fires. And that establishes an issue because that means those places are at risk of that sort of type conversion process starting to play out. We've seen this in really big fires, like in San Diego County. What you're looking at here are two fire perimeters, and where they overlap is this darker orange here. So this was the Esperanza fire. This is San Jacinto here, just to give you an idea of where we are. But the Esperanza fire burned in 2006, and then the 2013 Silver fire, 71% of that fire perimeter overlapped with the 2006 fire. So whether or not type conversion is happening in that overlap area is one question that should be answered. And I'm sure people look at those areas and do research on that. But the real issue here is the 2006 fire did not prevent the 2013 fire from becoming large and, burning many thousands of acres, right? But that's something that is just sort of entrenched in the way people think in Southern California. Is like, well, if we had burned it more recently, it wouldn't have been this next fire wouldn't have burned as large. And we see again, time and time again, this was the Witch Fire in 2007. In large portions of it reburned areas that had just burned 4 years previously in the Paradise Fire and the Cedar Fire. And that's a major issue in those areas. Now, I want to just talk a little bit about some fire frequency. I want to talk a little bit more about fire and show you some fire data. And I want to show you some of the LA fire data that I've been compiling. So this is the state of California, 1925 to 2024. We can just look at the number of fires. If we were in a classroom setting, I'd ask, what areas do you see have more higher fire frequency than other areas? And you would raise your hand and you'd say, oh, well, it looks like Southern California's got a lot of red there. And indeed, let's zoom in on that, right? There are a lot of areas that have experienced a lot of fires in the last just 1 century. Remember, the natural fire rotation for chaparral is 30 to 100 plus years. So the fact that we're seeing a lot of these areas have more than 5 or 4 or 5 or more than 5 fires in that century is not exactly what we want to be seeing, for these areas that have chaparral. And I should mention too, as you start to type convert from chaparral to these non-native grasslands, the frequency of fire tends to increase. It becomes like a feedback loop because those grass fires are the really ignitable. Grass is these non-native annual grasses are very ignitable. They spread very quickly, and they tend to beget the conditions that allow them to persist on the landscape. And one of those conditions is more frequent fire. So I just want to give you a sense of the urban area. So this is all this gray area is sort of the urban, this is the LA metropolitan area. And so you can see the LA metropolitan area has been surrounded by fire for the last century and much longer before that, right? This is nothing new about the fact that fire is burning or has burned in these hills around LA. Now, a lot of people will start to talk about, well, we have more large fires now and not enough small fires. And it's hard to really get at historical fire size, especially prior to prior to 1950, but even really prior to 1930, we have a hard time at getting at specific acreages, right? The size of fires. These are some fires that are in a database that I have access to from before 1925. I think this is like 1878 to 1925. And you can see there are plenty of large 50,000 acre plus fires on the landscape. There are also a lot of smaller fires, less than 50,000 acres. That's the blue here. In the 20s and 30s and 40s, the 25-year period here, we did have some big ones like the Matilaha fire, really massive fire that was in 1932, burned through a large part of Ventura County in the Los Padres National Forest before it was even known as the Los Padres National Forest. And that fire has been studied quite a bit in the decades since. So, big fires of course, have happened in the past. We also know about the, I think it's the Santiago Canyon fire of 1889. That one has been estimated to be about 300,000 acres in size. So that would actually be larger than, I believe, all of the current modern large fires in Southern California. And that was down in this region down here. So we've had big fires in the past. We continue to have them. This was in the period 1950 to 1974. I hear a lot of folks who grew up in this time period say that they don't remember big fires happening. And, we did a lot more logging and grazing and this or that on the landscape, and we didn't have big fires. You had big fires in Southern California. You just were a kid and don't remember, or I don't know what's going on, but we've got the data, plenty of big fires. This area where I live in this region here, and I'm very familiar with this area. The whole Western Santa Ynez Mountains burned in the 1955 Refugio fire, for example. And then there have been subsequent several smaller fires in recent decades in those areas, and people act like this has never happened before, and it has. And in a lot of cases, the fires that we had historically were bigger than the fires we have in the modern era. It's just, it's about looking through the data here. I will say we had, in terms of larger fires, kind of a quieter period in the 1975 to 1999, that quarter century. There was a big one, the Wheeler fire, Wheeler Peak fire, 1985. Lots and lots of smaller fires, though, smaller than 50,000 acres, but some of those are pretty big, like in the 40 plus thousand acres size range. Now, you look at the modern era, the last 25 years or so, we've had some really big fires. We've had a lot of them. And don't get me wrong, there's a lot more of the big fires in this modern era. But the issue is not so much that the size of the fires are necessarily unique, or the fact that they burned at all. And none of that is really unique. What's unique is that we have more, these are all of these were caused by humans. And we have more human caused ignitions lining up with this window of really favorable fire weather conditions. And when I mean favorable, I mean like for big fire growth. It's like Santa Ana winds. We have a lot of these fires occurred under extreme Santa Ana wind conditions. And it's because of these human caused ignitions. So we have this issue. We have more people in the landscape than we've ever had. We have more sort of different causes of fire than ever before. Now, some research has shown that certain causes like accidental fires, campfire escapes and stuff have reduced, in terms of number of ignitions, but we're seeing a lot more power line ignitions, for example, and those tend to occur under the most extreme weather conditions where we're going to have really big fires. So I think that is an important thing to understand. Again, just look, I want to just kind of go back to this little area. Look at all those fires here. Those range from, I don't know, less than 10,000 acres to about 20,000 acres. That whole area, that same exact area burned all in one fire back in 1955. So this is not that unusual over the, this last century. The fact that we have large fires is not unusual. What is unusual is just the sheer number of fires that we have, and the fact that they tend to be occurring under the most extreme conditions, and the conditions are becoming more extreme. That's another issue. So if we look at this whole area, we look at the time since the last fire, you can see a lot of Southern California chaparral is fairly young. And so we can think of this another way as it's, people might look at this and say, oh, well, it's at lower risk for fire because it's younger chaparral. I wouldn't look at it that way. I would look at it as it's at higher risk of being reburned too soon and starting to go down that type conversion path. That's where the actual risk is from an ecological perspective. So let's talk about the fires that happened recently. I included on this map, I don't even remember what I made this map for. I've made so many maps over the last couple of weeks. But I included two fires that are from last year, from late last year. I'm not really going to talk about the mountain fire, although I could talk about that quite a bit because I live very close to it and I know this area pretty well. So I'm mainly going to focus on the Eaton Palisades and the Hughes fire, but I will talk a little bit about the Franklin fire as well. But this is where these fires are where what was burning in this earlier this month that caused so much community destruction and got a lot of attention in the news. Anyone that has suggested that these are forest fires, those people are wildly incorrect. So let's just look at some vegetation type data here. This is look at the pink. The pink is the darker pink. That is chaparral and coastal sage scrub. That is the vast majority of what has burned. The only fire, actually, of all these fires that had any amount of forest in it was the Eaton fire up at the higher elevations where it burned near Mount Wilson. And it mainly was burning in that forest type I was mentioning earlier, big cone Douglas fir, the one that tends to be kind of surrounded by chaparral. I'll talk a little bit more about that here in a bit. I think these numbers are slightly out of date, but they're probably still correct. But only when you look at all of the ones that burned earlier this month, only about 3.1% of the landscape that burned could be considered forested. So if you hear politicians talking about, this is a problem with forest management, we haven't done enough of this in our forest, we need to do more logging, whatever. These fires aren't even really related to forest at all. They just don't have anything to do with forest in the way we think about forest, right? Now, of course, if you want to really adopt the term elfin forest, I guess you could make some argument that they are elfin forest fires, but please don't get elfin forest mixed up with conifer forest that we think of in like the Sierra Nevada. So let's look at the Palisades fire. Again, complete no forest whatsoever, very much dominated by chaparral and coastal sage scrub, but a big part of what burned was actually urban area. And that is the community destruction part, right? Huge swaths of the Pacific Palisades burning and homes being lost there, thousands and thousands of homes. Now, I also want to just look at the Franklin fire. This burned in December of 2024, and this burned in the Malibu area. So let's talk about these in terms of some historical fires, because I think what I wish we could move past, we have to stop being surprised that these kind of fires occur and that they cause community damage. This should not be a surprise to anyone anymore. It seems shocking, and you read the news and it just seems like this has never ever happened before. And granted, the level of community destruction has not happened before in Southern California. But the fact that it happened should not actually be nearly as surprising as people think. So in 1938, much of the area that burned in the Palisades fire burned in the Topanga fire of 1938. This is just from a newspaper article where you can see the hillsides burning, and homes were lost. Big difference here is there weren't as many homes built in this area. So like the wildland urban interface had really been developed after 1938 throughout this area here. So we have this big fire burning through this area, and then we start to build more homes after that fire. Kind of like, to some extent, like building homes in a floodplain after a giant flood, right? We just tend to sort of forget about the last fire, and we think we'll be able to stop the next. We'll be able to prevent the next one from happening, right? And I'm not trying to blame individual homeowners or anything like that. This is really more about like zoning laws and developers and stuff. This is not about individual homeowners. Please don't take it that way. After the 38 fire, there was the 1961 Topanga Canyon fire, burned a lot of homes. You can see a lot of the same sort of imagery that we see in a lot of the news articles today. Again, similar situation, right? After that, we saw in 1970, the Wright fire burned a bunch of homes in the Malibu area. This was a huge fire, much bigger than the Palisades fire. And again, the fact that the Franklin fire occurred should not really be that surprising. We knew that in 1970 this area is fire prone, right? And then in 1993 we see the old Topanga fire happen, and a lot of the media attention, it's very, very, very similar. It's like extremely reminiscent. You could read some of these articles from 1993, and if you just replace the dates with 2025, it would look exactly, you would think you're reading the same thing as today, right? But yet today we're acting like this is some new thing that's never happened before, and that it completely caught everyone by surprise. And that's a little frustrating, because The data are there. We know that these areas are fire prone. And this is what we see. This is in Ventura. This is an area that would go on to burn in the Thomas fire. In this area right here that you're looking at had burned several times leading up to just the year that this imagery was taken. So look at this area. You got a bunch of row crop agriculture. You got some pasture land here. And then it was heavily developed over the course of several decades in the latter half of the 20th century. And then the Thomas fire came through, burned kind of the same exact areas that we would expect for it to burn based on previous fire history. And you can see the sheer amount of home loss through this area. If we did the same aerial imagery analysis in Malibu or the Pacific Palisades area, we'd see a lot of the same things. I just haven't had a chance to do that yet. So we have to stop being surprised that these things are happening. I will say, the one thing that was really shockingly different about these fires, there's nothing that remarkable about their size or where they burned. What is remarkable is that they burned in January the way they did. And that is a problem. That's an issue that we're probably going to see more and more because of climate change, is just that extension of the fire season into times where we're not really used to that. The problem is that the Santa Ana wind sort of window does tend to be more in the wetter months. And so we're seeing fire season get pushed more and more into the Santa Ana wind season, and that will have major ramifications. I do want to just mention the Eaton fire, similar situation here. This is the Eaton fire. And one thing I want to make sure is clear, yeah, it did burn a little bit of forest up here. The fire started over here, and then it burned Altadena down, much of Altadena. And then it started to go up into the Angeles National Forest. It started to back up into those mountains. And it actually stopped once it started getting into that higher elevation conifer forest, right? So please don't think that the fire started up here, burned through forest, and then burned down the town. That's not what happened. But that is the way some politicians are making it sound like, that's what happened. Now, I'm going to change up the color scheme here. The gray, again, is the urban area. Let's look back in time, 1979. We see a big fire burning much of the same area. I saw these exact same news articles recently about the Eaton fire, threatening Mount Wilson and all the equipment up there, the television, the radar dishes, and I don't know about radar. I don't know what equipment's up there is up there, but there's an observatory. So the Pinecrest fire, a lot of the same thing, a lot of the same imagery. And then more pertinent, I would say, is the 1993 Kinaloa fire, which this was part of a pretty big firestorm in 1993, where people were talking about the ring of fire around LA back then. And so that's something that I've heard multiple times this year is about this ring of fire. I would say the one around LA in 1993 was even worse. And not from a community destruction standpoint, but from just the number of fires and how large they were. The 1993 Kinaloa fire was one of those, and it did burn down a couple hundred homes in Altadena. And again, the amount of destruction this time in the Eaton fire is staggering. But we should have been able to see that this was a possibility because of past fire history. And I think that there is a major problem with the way policy has been implemented over the last several decades in terms of not giving communities what they need in terms of home hardening, making structures more ignition resistant, and also better zoning and evacuation and alert systems. There are so many different things that we could be doing that would be focused on communities, but instead, the state and the federal government have largely focused on remote area wildland vegetation management. And that has been shown, especially in Southern California, to not really matter much when it comes to these big wind-driven fires. These are inevitable, and we're going to keep seeing this. This is a news story from 1993 about that fire in Altadena. You could read this, again, put the blinders on. You would think you're reading it today. They're talking about oh, these are the kind of fires we're going to expect more and more in the future, where they burn a bunch of homes down. And they talk about, a lot of the same things that we're talking about right now. So it's a little shocking to me that people are so shocked. I get the amount of community destruction is staggering, and it's horrible. I mean, it is absolutely devastating. And countless people have been affected by this. We we need to learn from this. Unlike the last several times, we need to get out of the cycle of thinking, well, we'll just stop the fire next time. We'll prevent it. We'll do enough vegetation management and we won't allow the fire to get to the community. We got to get out of that mode of thinking. This was a quote from that article from, again, 1993. So almost 30 years ago now. So lastly, I'll just leave you with this. These are some of the big fires that I was just able to throw together real quickly, just kind of looking up some data here. And look at this. All these fires that have caused massive amounts of structure loss and fatalities and a lot of acreage burn, they all have the same recipe, which is they're in an area with dry vegetation that is naturally dry during long portions of the year. And then a big wind event happens, whether it's Santa Ana winds in Southern California, Sundowner winds in the Santa Barbara area, Diablo winds up in the Bay area, that area. Those winds kick up, and it doesn't really matter what has happened on the landscape leading up to that in terms of vegetation management. You're going to get a fire that can move quite a distance along the landscape and can burn down a lot of homes, mainly from ignitions. So I recommend everyone who's interested in this topic, please read this piece by Kalkin et al. That just came out. This came out, I think, in 2023 or 2024, I forget. But they talk about how wildland urban interface fire disasters are not actually a wildfire problem. And, until the wildland urban interface fire problem statement is redefined to recognize the key role of structure ignition and focus on creating ignition resistant communities, risk reduction strategies will continue to be ineffective and insufficient. And what they're talking about there, risk reduction strategies, that's at the state and federal level, which is largely focused on fuel reduction in wildland areas. That we've been doing that for decades. It is not getting us anywhere in terms of community protection. And I hope we can learn something from these fires. I will take questions now. I went a little longer than I meant to, but
Thank you, Bryant. I really appreciated this. And one of the interesting things was how long it takes for the seed banks to grow enough to provide the source for regeneration. That was really illuminating for me. So thank you. So we have a bunch of questions. The first one is, does chaparral lend itself to a definition?
Yeah, I mean, honestly, there's a little bit. I've posted things on social media, and then other, botanists who have been around for a long time didn't like that I just referred to things broadly as chaparral because there's so many different types of chaparral. It can be a little hard to define, but what I was talking about mostly in this context was that Southern California kind of classic mixed chaparral that is the climax community. It's not like it's on its way to becoming forest if it just goes long enough without fire. That's not how it works, where this type of chaparral is dominant. But yes, it can be a little bit trickier to define than you would expect.
Is there a way you would define it then?
I would just say it is a sclerophyllous shrubland ecosystem that is adapted to the Mediterranean climate that we have here in California. If you're curious about that word, sclerophyllous, first of all, be impressed that I was able to say it 2 times in a row, because often I can't say it 2 times in a row or even once in a row. But that just means it's these evergreen shrubs that have these small leathery leaves, usually kind of waxy, very well adapted to very dry conditions. And so there are other sclerophyllous ecosystems across the world, mainly in these other Mediterranean climates, but we do actually have a few other ones in North America that are not in Mediterranean climates and have some connection. If you go back enough in the millions of years, you'll see some connections with chaparral. It's pretty interesting. Rick Halsey and I wrote a paper about that a few years ago. So if you look up Baker and Halsey 2020 about chaparral, we talk a little bit about some of those interesting connections with other sclerophyll shrublands.
Very interesting. Second question, does chaparral tend to have shallow topsoil that won't support tree roots?
Okay, good question. You're getting at a really important part of chaparral ecology, which is talking about edaphic conditions, soil conditions. I will say where chaparral tends to dominate, it's not necessarily that trees couldn't grow there because of some soil type issue. There are definitely places like that for sure. It's more about the amount of precipitation. It's about the climate of that specific area, right? And so think of it as in Southern California, we sometimes, if I were to hike from where I live, almost at sea level, hike up into the mountains in Ventura County and try to get to the highest point, I will eventually get out of the Chaparral sort of belt and I'll get into a mixed conifer forest belt. And then I won't be able to really find the tree line above that. So it's almost like a reverse tree line, right? Where you get out of the Chaparral and you get above a point where trees are able to start growing because of that climate. Those climate conditions are more conducive. Granted, there are places, especially where we talk about montane chaparral, a lot of times montane chaparral that is sort of mixed in with forest, it is because of edaphic conditions that don't allow trees to grow in those spots. And if you want to learn more about how important soil conditions are and the soil types are for diversity in chaparral, I would recommend, there's a great book, a field guide. It's called A Field Guide to Manzanitas. And the authors talk a lot about, in the intro section, about edaphic conditions being quite responsible for the massive diversity that we have in terms of manzanitas. It's our most diverse woody genus in California. And most of the 107 species and subspecies and varieties that occur in the world, most of those occur in California. And a lot of them, they evolve because of edaphic conditions, which is pretty interesting.
Okay, is chaparral protected with state laws or CEQA? It is removed so often for cannabis in Lake County with no noticeable mitigations, per the person that posted this question.
Yeah, well, interesting. And yes, chaparral, I think historically has been heavily removed to open up areas for grazing. So to turn areas into pasture land, to turn areas into citrus and other, agricultural commodities. So it has not historically been protected. Portions of it, certain areas will be protected through, because it supports some endangered species, things like that. Kind of, you see that with any ecosystem, though. I don't know of any real protection that just sort of is extended to chaparral as an ecosystem. I will say there are, in some state regulations, some documents, you will see there is this acknowledgement of overly frequent fire in Southern California chaparral. And so the idea there would be, okay, we're not going to do certain like prescribed fire, for example, in these areas that are already experiencing too much fire, but they're not very binding. Usually the language isn't very binding. And so we often see things get done that probably should not be done in chaparral, even though an agency has acknowledged that what they're doing is not great ecologically. So yeah, I would just say generally across the board, no, there's not really some big protection for chaparral.
Next question. Help me understand. The chaparral is largely evergreen shrubs, per the questioner, but the slide for fires indicated crown fires.
Yes.
The questioner asks, is the crown like the upper canopy? What is the percentage for crown in the chaparral?
Okay, so I always get this question, and I've been trying to come up with a better way to describe the nature of fire in chaparral. Think of a crown as, yes, just the canopy, and think of shrubs. Their canopies tend to go all the way to the ground, right? That's one of the defining characteristic of a lot of shrubs. Now, you get enough shrubs pretty close together. I did like a whole photo series on the understory of chaparral. You will start to get kind of an understory developed in the sense that you can get underneath the canopy. It's not like things are growing under there because it's so shaded. But just the main point to take away is that when fire comes through, that whole canopy, that crown of every shrub is going to be burnt for the most part. Very, very seldom. You will get patches, these little patches that are maybe they're on a north-facing slope or something. Sometimes the fire just sort of skips areas. It can be quite random and chaotic. But you don't usually, I've never seen this, and I don't know that it's well documented. You don't see fire like going in the understory of these shrublands and not burning the canopy, right? Does that make sense? So when I say it's a crown fire regime, it just means that everything burns above ground. but you still have all those stems, those main stems. They tend not to like just poof, disappear, combust completely. Although you do see that a little bit with ceanothus, which is interesting. You saw that there was one photo with the seedlings and there was kind of a little stump. I've noticed that with ceanothus that it does seem like often the whole shrub just sort of combust above ground. But for the most part, those resprouting species, you still see the main stem is left behind, and it'll persist for years or decades after the fire, and then they'll resprout from the base. Hope that answers your question.
Did the questioner feel like that answered his or her question? Okay, well, if it didn't, we can put in another question in the chat. Thank you for the question. Here's the next question. We just heard at Board of Forestry that wildfires are bad for the climate, and so quote unquote vegetation management, broadly speaking, is better for the climate. Does that make sense to you? Ask the questioner.
That's an unwieldy question. Well, okay. I don't even know. I'm not sure where to start on that one. Is this, and maybe Kristen, you can just repeat it. What is this pertaining specifically to Chaparral?
No, it looks like
Might just be more broad.
the person that said this said that the Board of Forestry is saying that wildfires are bad for climate first, and then they're saying they need to do vegetation management broad, kind of in general.
Okay, I get it. Yeah. So the idea would be if we do enough vegetation management, we can prevent fires from being larger or more intense or something, and that we can somehow save carbon from leaving these systems. There have been some interesting studies on that in forested areas where, and there's debate about this, but there have been studies that have found that, like commercial thinning operations, for example, remove quite a bit more carbon than they save from being lost in a subsequent wildfire, right? Chaparral, there's not great carbon accounting in Chaparral just in general. There is a perception and there's kind of a myth that's been around for a long time that Chaparral, as it gets older and older and older, it just becomes like unproductive, and it just sort of dies and becomes senescent. That's been found to not be true, but yeah, it's a pretty broad question. And I would just say that when you look at carbon, like good carbon accounting, the more intensive types of vegetation treatments, like removing entire trees, especially larger trees, it removes a lot more carbon than would be lost in a subsequent fire. And a lot of times, like, especially with ecosystems like forested ecosystems, not nearly as much carbon is leaving the system as people think. And so there have been quite a few studies on this. A more recent one found that something like even in high intensity fires in forested areas where most or all of the trees are killed, you still only lose, maybe 1% to 2% of that above ground carbon. And that's because most of your carbon in a forest, in any given forest, is going to be in those trees, and especially the larger trees. And so they don't just combust and suddenly lose all their carbon to the atmosphere. They stick around for many decades after a fire. So there's some caveats there.
Thank you for that. Next question is, how can we bridge the gap in the knowledge of our policymakers and fire protection district personnel about stewardship and fire risk management? So meaning, essentially, how can we educate policymakers and fire protection district personnel, I think?
I've been trying that for the last many years, and I have colleagues who have been doing it for much longer than me. It is an uphill battle, it feels like. Every time I think that we are making some sort of headway, I've seen really good stuff come out of the Forest Service in terms of Southern California Chaparral. There's a book in 2018 called Valuing Chaparral. It's a really good book, and it goes quite in depth on a lot of these issues. And it was co-edited by a research ecologist at the Forest Service, who is the main research ecologist for the Southern California National Forest. And we've seen in specific projects that the Forest Service, where I'll give you an example. There's a project that we've been dealing with for several years now in Ventura County in the Los Padres National Forest, where this big fuel break would be put in place and about half the fuel break, or not about half, it's like 300 out of the 755 acres that would be turned into this fuel break is chaparral. And the Forest Service even sort of acknowledge in their project documents that fire is infrequent in chaparral, that it should be every 30 to 150 years. They even cited the California Chaparral Institute in all of this, and then just sort of went on to say that they've got to do this treatment. They've got to reduce the age of chaparral. They've got to, they even sort of mischaracterize the chaparral as a fire regime group that has high frequency of fire, like every 0 to 30 years. It can be a little baffling. So on the one hand, people are saying, oh yes, of course, we know chaparral has issues with high frequency of fire and we shouldn't be doing this or that there. And on the other hand, we see agencies doing this or that in chaparral. So how can we educate people? I mean, I honestly don't know at this point. I feel like I'm trying to do that now. I'm trying to educate folks. And if they talk to other people and, I definitely talk directly with staffers of politicians and policymakers. But people are very, very much scared of fire right now. And chaparral, as long as it's just considered brush, it's an easy scapegoat. It's an easy target. And I'm struggling to find the ways to overcome that. So it's not a great answer. I'm sorry, but that's where I'm at.
I'm sure a lot of people share some of the feelings you're having right now. So thank you. So the next question is, you mentioned the fire spreads from crown to crown. So I'm thinking the soil temperature does not reach the point where root systems are destroyed. The questioner asks, would you agree?
Excellent question. I give a much longer presentation usually, although this was longer than I thought it would be. I was telling folks before we started this, I was like, oh, this will only be like 30, 40 minutes. So I tend to go, I'm a kind of a lengthy presentation person, mainly because I want you all to understand the things that I know. I just want to download all the information into your brains. But I talk about this in other presentations. You can easily find these on our on Forest Watch, on our YouTube channel. We've done all sorts of webinars. It's a great question. And when I've said that a lot of plants resprout, what I usually talk about, I go in a little more depth about how they do that. They usually resprout from these big basal structures called burls. And think of these as almost like they look like giant woody tumors, and they're mostly buried underground. And they have all these buds that are protected from the fire, and they're able to easily resprout after the fire. Usually we think because of some, you imagine you lose all your foliage in an evergreen shrub. Suddenly there's a lot of chemicals, hormones and things not going down to the root system all of a sudden. And so the plant then knows, okay, I need to actually resprout from these buds that are still alive. So yes, the temperature usually does not affect those burls. And I've been in some really intensely burned areas, and it's hard to find burls that were just outright killed and didn't resprout. That's a kind of a rare thing to come across. In terms of seeds, this is a really fascinating thing. Manzanitas, for example, you'll often see the seedlings come up in little clusters. And there's been some research into this that has found that these clusters are from rodent caches, where they buried them in the soil deep enough that they weren't affected by the heat, but not too deep that they're not affected by chemicals from charred wood or smoke that basically causes some chemical change in their seed coat that allows them to open up and let water in, right? So that's an interesting aspect. I've found clusters of other species like bush poppy and ceanothus that are very possibly from ants that cache seeds deeper in the soil. But honestly, and I wish I had this photo, the heat penetration in the soil, it's not very much. And you look at the charred layer of soil, it's like this. I mean, seriously, I have this really cool photo where I sort of dug into the soil, and it's this inch layer of char, right? And you can just tell that there was not much heat penetration below that. So yes, and the fires move pretty quickly in these fires. And so there's just, it doesn't really destroy these root systems.
Interesting. So this question is along lines of the other question about education. Have you convinced any managers about the fact that annual prescribed fires would not work in chaparral systems? And how can such outreach be accomplished?
Yeah, annual fires would work totally to get rid of chaparral. That would be a great way to get rid of chaparral, is if you conducted annual fires. I'm not actually even sure it's possible. Like at some point you will just get those grasses coming in. And yes, once you get that grass establishment, you could probably do an annual fire. But the thought that people can just annually burn these systems is kind of a little bit bonkers to me. But have I successfully convinced anyone? I don't know. Maybe I've convinced somebody. I've certainly convinced people in Instagram messages and Facebook messages and comment sections. Sure, I've probably turned a couple of folks to some science. And policymakers, though, I don't know. It's really hard to say. I will say, though, that the National Park Service in the Santa Monica Mountains, they've had a long-standing policy of not conducting prescribed fire, because of all of the massive amount of work that's been done, especially in the Santa Monica Mountains, from a scientific standpoint, on the problems with overly frequent fire. So the science does get through to managers to some extent. It's just at this juncture, can that overcome the need to show the public that the managers are doing something about the fire crisis, right? And that's where I think we're stuck in this endless loop where we have these big disasters, right? Like what we just saw in the Palisades and Altadena. We have these disasters. Then we have the policymakers, we have the politicians jump in and say, we're going to do this and we're going to fix this problem. This isn't going to happen again. And what they end up doing is passing some legislation that basically just doubles down on the stuff that we've been doing for decades. We then will have another fire, right? We had the fire in 1993 in Altadena, and then we have this fire in 2025. In 2045, we'll have the next one, right? And nobody will hold those politicians accountable for not actually getting us out of this endless disaster-driven cycle where we're trying to respond to disasters with responses that don't actually respond to the disaster in the first place. So, yeah, if you can tell, I'm getting a little frustrated and worked up, but that's just because it's just amazing to me how history just keeps repeating itself.
Yeah, I think there was an article recently where somebody said, let's redefine it as a home ignition problem.
Exactly. Yep.
Yeah,
It's not a wildfire problem. It is an urban. I mean, if you really want to get at why are so many homes burning and people are dying, it is ultimately an urban fire problem. It just happens to be that the ignition sources are coming from the wildlands, right? And so short of making all of our wildlands urban areas, because that has been effective at reducing, there's a reason like the interior part of the LA metro area doesn't burn very often. But what do we lose in that process from an ecological standpoint, right? People are very concerned about climate change and biodiversity. We need those. We need these ecosystems. We need them to be there. They serve, endless purposes that are useful not only to all these species that live out there, but also to us. In fact, the national forests in Southern California were established in the early 1900s to protect the watersheds that they cover, right? It was to try to keep people from burning these areas, because every time, you have a big chaparral fire, you have risk of flooding, and you have soil that gets eroded and moved down into streams. And so people back then were very concerned about like how it's going to affect water quality in reservoirs. And so, I'm not even sure what the question was at this point.
I don't know, but water quality is another thing for us to keep, and flooding is another, and erosion is another thing for us all to keep in our heads and our minds. Okay, next question. Do you know if there are fungi in these soils that support the plant root systems with nutrients?
Probably, yes. I don't know much about fungal systems in chaparral. That's a great question. Will be my next, I'm sure, thing that I obsess about, trying to figure out what research has been done on that. It's a good question. Yeah, we know that in forest for sure. Mycorrhizal systems are very important to forest. I'm assuming there's something similar. There's probably some mycorrhizae in chaparral, but yeah, I don't know.
Okay, well, thanks to the questioner.
Yeah.
Okay, the next questioner says, I have heard that the carbon storing abilities of chaparral can far exceed that of a forest of the same age, since much is stored in root systems unaffected by fire. can you speak to the carbon lost from fire versus logging and thinning in these ecosystems? You did somewhat touch on that earlier.
I did a little bit. And honestly, I don't know about the first part of that question. I would need to look more into the numbers on that. Like I said, there hasn't been a lot of great carbon accounting in Chaparral, and a lot of that is very focused. What has been done is focused on above ground biomass, above ground carbon. I would say just in general, in terms of carbon accounting in ecosystems, regardless of ecosystem type, there's not as good of accounting for underground carbon, right? What's stored in root systems. The fact that Chaparral is so, I mean, most species are able to resprout in Chaparral. And I get this question sometimes, like how can we determine how old this toyon is? We can't. We can maybe we can look at tree rings, you know, of like a big mature toyon. And that would tell us how old how long ago it was that stem sprouted from its burl. But we actually don't know how old some of these species are. They could be much older than we expect, centuries old. It's just hard. It's hard to know. And therefore it's kind of hard to account for all that carbon that they've been accumulating and stuff. So great question. I just, I don't have a good answer for you.
It sounds like we're not really sure because we don't have as much data also. We're not sure of the comparison without the data.
The vast majority of research on Chaparral has been about how can we reduce fire risk in Chaparral? How can we change Chaparral so that it doesn't burn? That has been most research. You know, I remember trying to figure out like what lichens grow in Chaparral. Not a lot of research on that, right? Fungi, I don't know. I don't know if there's a lot of research. You know, what's the like, what are the decomposer invertebrate communities like in older Chaparral? I'm not really sure. You know, I don't know that there's been a lot of people studying that for the last several decades. It's not really where the grant money is. You know?
Right. Okay. So here's this very specific question. It says that CAL FIRE San Mateo County has a policy of frequent low intensity prescribed burns with the stated intention of converting shrub to grassland. Please confirm this is wrong if not illegal, or please confirm this is wrong if not illegal intentional habitat conversion.
It's kind of what I was getting at with, yes, the state, if they're using the VT, what is it called? The VTP, the vegetation treatment program. It's like this programmatic EIR for the whole state. And they are doing lots of fuel treatments under that. It's not supposed to result in type conversion, right? The problem is type conversion is a very difficult thing to both define and predict, okay? So there are plenty of areas that they burn in the Chaparral, they burn and they burn 4 years later, and it's comes back as Chaparral. Maybe you've lost some species. It's hard to know. I mean, there's been debate about this, like, okay, it actually converted from Chaparral to more like a coastal sage scrub. Is that really type conversion? This is the problem with this kind of language, and this is honestly the problem with a lot of legislation, is that it's just so vague that it can be interpreted in different ways. One thing I imagine in San Mateo County, people would probably argue, this would be my guess, that I would expect some agencies to say, well, Chaparral wasn't even supposed to be here in the first place. This was grassland historically, and then we stopped grazing it, burning it, whatever, and the Chaparral sort of invaded. And so we're actually just returning it to what it was. And that could be the case. Like, honestly, there are places where they may have been frequently burned, or they for whatever reason, they weren't as shrubby as they are today. That is certainly a possibility, and I'm sure it does occur in a lot of places. The question is are you going to like, is restoring it to a grassland, even though the grassland is dominated by non-native grasses, is that the best approach, you know, getting rid of whatever shrubs have come in? But then the real question is it really true? Maybe this area is climax Chaparral. That's what it's supposed to be. People are going to have different thoughts. And I know that there's sort of this kind of prohibition on type conversion from these projects. I'm just not sure how well any of that's going to be followed, or I don't know who gets held. I don't know how like the accountability on that works. So sorry, I probably didn't answer your question very well.
No, that's fine. And by the way, somebody else is on this. I'll state this question too, but it's kind of along the same topic. Somebody else said CAL FIRE literally said they want to destroy Chaparral, scrub is what they call it, to grasslands. to convert it to grasslands despite a state law against this conversion, and Cal Fire later revised the MND to delete this, yet kept all their actions the same. And what can be done to address this? It kind of sounds like that's along the same lines of the question you've just been addressing, right?
Yeah, it's tough. And check out Rick Halsey at the California Chaparral Institute. He's been fighting the big statewide EIR for many years now, and he's got some good information on his website about that. But yeah, it's not a great situation just generally across the board.
Okay, thanks. So, different question. Do you know if there's a history of indigenous cultural burning in Southern California?
Yeah, absolutely. Definitely is. Definitely a history of cultural burning. Very hard to put really solid numbers and specific areas. All of that is very difficult. We don't have, there's a lot less evidence of just a lot of things going back in time in Southern California. Like we don't have tree rings, right? For most areas, we can't look at fire scars and tree rings as an example. But there have been some good ethnographic studies on this. I will say the probably majority, like where burning was most intensive, very, very likely in the areas that are currently under concrete right now. There's a reason why the LA metro area, the LA basin was colonized the way it was and why it has developed the way it has, because it is more conducive to where people live. We know that a lot of that area was grassland, savanna, oak woodlands, wetlands. All of that has been converted. That's probably where the most intensive like indigenous management was happening historically pre-colonization. It's harder to say in the mountains. It's a little bit more difficult to say exactly what extent it was. It was probably certainly happening in certain areas. I would just, people get really hung up on, well, maybe if we just did more prescribed fire in Chaparral, whether that's cultural burning or it's Cal Fire doing it or the Forest Service, whatever. You have to just go back to the basics, the fundamentals on Chaparral, which is that it cannot persist over a long period of time under high frequency of fire, right? So if Chaparral is the predominant ecosystem in an area, and like mature Chaparral is pretty good at being resistant to invasion by non-native plants like wild oats or cheatgrass at higher elevations or black mustard, right? Adding more fire to it, even though it's already at risk of overly frequent fire or really short fire intervals, it just, you're creating a risk, you're increasing the risk of those areas becoming, those non-native plants becoming more established in those areas and exacerbating fire problems and causing biodiversity issues, right? We have to remember that prior to colonization, there were no non-native plants on the landscape, right? And so it's undoubtedly true that there were all sorts of different indigenous groups that were purposefully probably type converting Chaparral to to vegetation types that were more conducive in terms of like food and fiber products, right? Things that were more edible. There's pretty good evidence of that in some areas. And so again, this is kind of what I was trying to get at earlier, like converting one native ecosystem type to a different native ecosystem type. That's one thing, but converting it from a native ecosystem to something that is dominated by non-natives, that is generally a problem across the board. And so your question is really good. And there are some good resources out there to learn about that. It's just, I think people tend to try to take something from pre-colonization and apply it to the modern landscape today without thinking through all of these little issues that magnify like the presence of invasive plants. There's a lot more to all that, but just go back to high frequency fire it doesn't allow Chaparral to persist in the long term. And if we want Chaparral to persist in the long term, we should probably avoid the high frequency fire. Does that make sense?
Yeah, it sounds like a key takeaway for all of us to bring.
Yeah, it's a pretty important concept to take away for sure.
Yeah. So another person asks, we are seeing more and more open space previously closed to recreation opening up, the person says. And they ask, do you think this increased human use of open space contributes to increased fires?
That's a good question. It's possible. Yeah, it's possible. I will say, you look back through some historical documents about like national forest in the earlier 1900s when the forests were first being established. I do come across a lot of the Forest Service sort of closing areas during high fire danger time periods, right? Like when the red flag warnings are up, the Santa winds are going, it's very dry, we're in the late part of the year, we haven't had any rain. Areas would get closed to like hunters and to hikers and stuff. There was this, if you go back through and read any like that Francis Fultz book from 1923, definitely a lot of thoughts about careless hunters. That was like, I think most fires that were human caused were just assumed to be from some random hunter out in the middle of nowhere who like let their campfire go. I don't know how well attested that actually is. Like, I don't know if we have good data on that. I'm just saying there was a lot of attention on that. It didn't matter so much. I mean, I think ignitions are going to happen on the landscape. We can definitely do better to try to reduce ignitions. I think a big one would be focusing on utilities and trying to figure out what are the best ways that we can reduce those ignitions, because those tend to happen under extreme weather conditions. There's a reason those those power lines are causing ignitions. It might be because lines are flapping and they touch and they cause sparks, right? That occurs because of extreme winds. And so I think there's work moving in that direction to try to tackle that issue. In terms of other causes, I mean, I'm sure there's more we can do. We do know that a lot of ignitions disproportionately start closer to roads. It's just hard. It's really hard to say, if this area gets opened up to recreation, ignition risk will be higher. The data more broadly show that as the population density increases in an area, ignition risk goes up. So we do need to keep that in mind, right? And I think we've got to stop this developing outward approach that has been the norm for the last century in like Southern California. And we got to start thinking about that developing upward approach, because it's this growth of the wildland urban interface it's getting us into some feedback loops where we are increasing the risk of ignition. We're also putting people in harm's way, and we're just going to see more and more disasters like we've just seen this month. If we don't figure that out. So I hope that kind of gets at your question.
Yeah. And by the way, another person was along the same lines. Do we have reliable data on causes of chaparral fires, either recent or historical?
I see that question in the chat. That is almost exactly my name. It kind of confused me. I was like, so yes, Brian, good question. Do we have reliable data on causes of chaparral fires? We have it both for historical and current and modern fires. We do have pretty reliable data. Pre-1950, it gets less reliable. There have been some interesting studies about ignitions. There have been some in the 2010s that, like I was saying, some ignition causes that were like ignition sources that were really common historically are less common now. They're a smaller and smaller percentage of the ignition sort of landscape. I don't know how to describe that, but so yes, I would say power lines are a good example of an ignition source that has been increasing over in the modern era compared to historically. But things like dropping your cigarette in an area, carelessness, that's decreasing, right? We're probably seeing an increase in probably firework ignitions and gender reveal party ignitions. I think we are probably seeing an increase in that. I don't know if anyone studied that specifically, but I have seen a disturbing number of news articles about this fire or that fire being started by a gender reveal party. I don't know what people are doing to reveal the gender of their baby. It does not need to involve anything that has explosives. Please stop doing that. You can use something else to do that. But yeah, there's definitely data out there.
Okay, got it. So another person was just continuing the line of indigenous culture burning. I think you might have answered this, but the question is, how widespread was it?
Very hard to put a number on it.
Okay.
Probably impossible. So
Okay. Yeah, and you mentioned it was probably more in the flatlands, but it's hard to say.
There's definitely data that suggests that it in Southern California, at least, it was closer to settlements, permanent settlements, and those tended to be concentrated in places like the LA Basin or the San Fernando Valley, places where there was year-round water, and a lot of oak woodland. That was another thing. But yeah, it's just really difficult. And there have definitely been, there's been debate in the scientific literature. I'm sure people talk about it still a lot, but it's very hard to say with any certainty.
Right. Right.
So, Brian, I'm wondering how you're doing here. We're more than a half an hour over. I'm wondering if you're
Fine. I can keep talking as long as anyone has questions. I know that, yeah, other people I know people are dropping off, but if people still want to, I know we haven't gotten through, we're like halfway through the
I know
call.
we've got so
Oh
many
my
more. So I guess my thought, Karen, was could we go till 6? How does that sound, Bryant?
That's fine with me. Yeah.
Just try to get through as many as we can. And if not, I can send you the whole chat. And if you want to take a stab at any of the other ones later. And everybody, I want you to all know Bryant is going to be having some talks via Los Padres Forest Watch that are going to be coming up.
Yep.
Maybe you could mention that to them, just in case.
Yeah, I'm going to be doing 2 webinars on Thursday, one at noon and one at 6:30 p.m. Pacific time. And so I'm going to be talking a lot more about this stuff. I'm going to be covering a lot of the same things, and I'm going to be answering questions. I'm going to try to make those a little bit more Q&A style, and it's mainly in response to our organization posted a video on Instagram a couple weeks ago, last week. I don't remember when it was, but it went kind of viral, and it was about trying to de-link, these fires in LA from the idea of forest management. Like they don't have anything to do with forest. And boy, like a lot of people had a lot of thoughts about that. And so I wanted to just kind of have a webinar so that we could cover some of the basics around Chaparral fire. But
that'll be great. And so let's see. And will you be able to put the link in the chat just so?
Yeah, I put both of the links in the chat. Yeah.
Great. That's great. Okay. Thank you. Okay. So one person asks, does most of this apply to the Bay Area as well in terms of Chaparral?
That's tough. There's some really fascinating chaparral in the Bay Area. There's some cool maritime chaparral closer to the coast. There's definitely going to be some interior chaparral before it just turns into grasslands in the Central Valley. Does it apply exactly? It's hard to say. You do have Diablo winds up there. And in fact, I will say the Oakland Hills fire. When was that? 1991, maybe? When was that? 1991, Oakland Hills fire. That destroyed 3,200 structures in the Oakland Hills area. That was Diablo wind, 70 miles per hour. It was in grassland. And in fact, the way it started, it was a fire that had just been put out days or weeks before, and it had rekindled and under these extreme winds and burned down a bunch of homes. That actually led to a lot of changes in terms of roof material policy. And so there were updates, changes made to building codes to require non-flammable roofs. And so a lot of the same concepts in terms of the risk to communities is the same. You still have wind-driven fire events there. Whether or not the chaparral, its exact fire regime in that area and how it responds to frequent fire, that's going to be a little bit trickier to pinpoint. And I just think it's because there hasn't been as much attention on chaparral in that area. But you still have in that whole vicinity, anywhere where you find chaparral, you have species that are obligate seeders. Okay. So I know Maya Kosela's here, and she's shown me some different areas in Sonoma, different projects, big fuel treatment projects and stuff. And I have looked at what species of manzanitas occur there, and several of them are obligate seeders. And so you have to think some of these species are probably also at risk of overly frequent fire in those same areas because they have the same sort of basic traits, right? They need time to build up their seed bank. They have to get to maturity first, build up a seed bank. There's not as much literature on it, I would say.
Okay, that'll be interesting for those of us in the Bay Area to keep looking into that. Okay, so I skipped through a bunch of comments, because they were all comments. I'll send you the chat afterwards. Lots of thank yous and lots of people thinking a lot about this topic. So here's another fire cause related question. Somebody asks, it looks like more often than not the fires are caused by human. Is that true? Ironic if so. The problem is not the fuel, it's the fire. I know you addressed this, but
yeah, we often say 95% of the fires in Southern California are human caused. It is much closer to 100% when you start talking about those larger fires. I was actually thinking, I showed a map that was like 2000 to 2024 large fires. It was like orange fires, and then there were some blue ones. Those were the smaller fires. I don't know that a single one of those large fires was not human caused. And that is the case for the vast majority of the big fires. It has a lot to do with the fact that lightning frequency is so, the rate of lightning strikes is very low in Southern California in general. And it's actually pretty low across a lot of California. People may not realize that, especially lightning strikes that coincide with conditions that are conducive for fire spread, right? So a lot of times lightning happens with rain, right? And so maybe you get some small ignition, but it gets put out by rain. In Southern California, most of our lightning strikes are during the winter, during the rainy season. And there's a thought that historically what may have happened was that you'd get lightning strikes in the summer at higher elevations, maybe in the forested areas. And those would like be small fires that would smolder over until the Santa Ana winds came through, picked them up, and caused the fire to spread down the mountains toward the coast. And that's how those big events happen. There's also other data that suggests that even prior to colonization, humans were probably accidentally starting fires under extreme weather conditions. And we probably can't discount that that's a possibility as well. So yeah, it's mostly, though, the modern era, it's the vast majority is human caused.
okay, here's another question. Is there any data on the carbon storage of ceanothus, say in the, I'm going to butcher this, Cuyamaca Mountains?
Cuyamaca, yeah.
Cuyamaca.
What a strangely specific question.
And the rest of the question is after fire versus the pine forest that managers are often trying to replant.
Well, that's an interesting situation. Yeah, so the long and short of it is there was a big fire. What was that? Would that have been the Cedar Fire of 2003? Burned the Rancho Cuyamaca State Park, I believe. And there were some pine forests in an area of that state park that had burned at high severity. And what happened was a lot of it, I think, was coulter pine, which is an interesting species that you often see kind of associated with chaparral. The pines died. And what came up was a lot of ceanothus. I believe it was deerbrush, Ceanothus integramus. And it came up quite abundantly, very thickly. And this is what I was mentioning very early on. I said something about episodic chaparral. It's a pretty good example where this was deerbrush, Ceanothus. This was like chaparral that had not been seen in that area because it was forested for quite a long time. The forest is reset to an early succession stage because of high intensity fire. And you have this fire cued seed bank that suddenly gets queued up. It germinates. And one of the cool things I have not mentioned yet is that Ceanothus is, despite not being in the legume family, is a nitrogen fixing species. So there's a thought that a lot of plants that do really well post fire are nitrogen fixers because nitrogen is one of the few nutrients that you lose during a fire. It gets volatilized. And so there's a thought that the Ceanothus is maybe putting nitrogen back in the ground, and that's what's going to help over time prep the landscape for pines to reestablish. There have been some interesting studies on that showing that, the pines were reestablishing on their own, and it was going to take some time, but it was happening. But what I believe the state did was they ended up going in and clearing all of that deerbrush and then replanting a lot of those pines. And so, I don't think very many people, I don't know that there's been really any specific studies on that. Actually, the paper that Rick and I wrote in 2020, we did talk about that specific example as an issue. But I don't think we didn't really have any like specific data to present on that. So that's one problem. And I would say just in general, just beyond that area, it's not a really well-studied issue. And it's happening very, very commonly in the Sierra Nevada and other parts of California, where you see that early succession forest stage that is dominated by these nitrogen-fixing shrubs like ceanothus. Those are getting cleared, including manzanitas too. They're getting cleared or they're sprayed with herbicides during salvage logging operations or after salvage logging, and then they will replant trees. And that there are definitely some carbon implications there. I know that, it was ceanothus palmeri, and then Jeffrey and Coulter pines with a few sugar pines. Okay, yeah, this is all coming back to me. Ceanothus palmeri, very, very similar actually to ceanothus integramus. Yeah, so Palmer ceanothus. I don't have I don't have much more to say other than that, but interesting question, very interesting issue. It's kind of niche, a little more advanced. It's a Chaparral topic.
Okay, you know what? All the rest of the comments were comments. Is there anyone that had a question that would like it to be answered?
Can't believe this many people are still here.
I know. So many of the other questions were comments. Hi, Kimberly.
Hi, just that question about the chemicals dropped on some of these areas.
Oh, sorry, I missed that. I must have
The
skipped
impact
it
from
over.
that?
Thank you, Kimberly. I'm looking for it.
Was it about Phos-Chek, like the fire retardant?
Yes.
Yeah, I bet is your question, how does that, what are the like long-term impacts on ecosystems and things like that?
Yeah, so what are the short-term impacts and then what are the long-term impacts? Does it have an impact at all on the ecosystem?
Great question. And it's one of those things that hasn't been very well studied. The main sort of way that people have focused in on that issue has been about how it affects aquatic ecosystems. And so when you drop a bunch of fertilizer, this Phos-Chek, it's a lot of phosphorus, right? And you drop that into some aquatic system, you can cause a pretty quick amount of you can cause eutrophication, you can cause algal blooms, you can cause fish kills. There's all these things that can happen that have been fairly well documented, and it's one of the reasons why CAL FIRE and the Forest Service are not supposed to be dropping Phos-Chek, this red retardant, on aquatic, riparian areas, aquatic systems. There's a difference between not supposed to and what actually happens, because they're dropping it in aquatic systems all the time, and it's quite brazen sometimes. Like they'll literally, I've seen retardant drops like along, like following riparian areas. So which is an interesting tactic. But in terms of terrestrial systems, like how does it affect Chaparral, for instance? It hasn't been well studied. And I know that there was a group at Cal Poly that was trying to do some work on what were the long-term implications of putting a bunch of phosphorus into this system, or I think, there's also some nitrogen as well, putting all this fertilizer into the system, and how does that affect like what comes up post-fire? Because remember that, like I just said, a lot of those fire following species, a lot of species that do well after fire, they do well because of those lower nitrogen conditions, and they have a competitive advantage. I just don't know what the longer term results of that. I haven't seen any papers that have really gone into that, but I haven't looked super hard lately. So that's something that I'll try to look up. But yeah, it's a good question.
Thanks, Kimberly, for that. Is there anybody else who had a question that wasn't answered or would like to add one?
David has a question that he just posted. What are the top 3 things we can do to reduce devastating fires? Good question. Boiling it down to 3 can be tough. I would say the number one thing is, let's assume that the fires are going to happen, right? Best as a society to get out of this mindset of we will stop the wildfire from ever happening in the first place or from getting to a community. Let's dispense with that idea for now, just for now. So that's one. It's kind of like part one, part A, right? Okay. Part B of that would be focus on communities, home hardening, defensible space, making sure that people have good alert systems, that people are going to be notified of a fast moving fire that's going to impact their community, and making sure that they have evacuation systems that are ample, right? A lot of communities have been built into these like one way in, one way out canyons. And it's a very dangerous situation under a fast moving fire. We are going to have to find ways at addressing that as a society. So that's the main one, right? Is let's focus on communities. The second one, so that's like short term. We can do that. We can do that now. We can really start working on that now. The second one kind of gets back at that part 1A, right? Is let's assume that the fires are going to happen and impact our communities, would be to do something about climate change, right? We really do need to get a handle on climate change. We're seeing pretty big influences of climate change on fire activity, and a lot of the Western United States, for example. I think even in the Southern California, where the climate signal hasn't been as strong with fire activity, I think we just saw it in these big January fires, right? And we're going to probably see more and more of that in the future. So that's another one. And then I think number 3 would probably be preventing ignitions under extreme weather conditions. If there's a way we can actually get at that. I know that kind of contradicts a little bit with what I said in part 1. Let's assume that the fires are going to happen and affect us, but there is a lot I think we can do to try to address power line ignitions, for example, those ignitions that occur under the extreme or more extreme end of the weather conditions. All of that can move us in a direction where we can live with natural fire on the landscape, and while also protecting our communities. There's probably a lot more to that. That's like on the spot, my top 3, but. Yeah.
Well, thank you, Bryant. So how can people find the information if they want to go to some of your future talks?
Yeah, go to Los Padres Forest Watch's website. It's either lpfw.org or you can go to forestwatch.org. Those take you to the same place. Follow us on Instagram at LP Forest Watch. That would be a good one. We send out an email. We send out like e-newsletters and stuff like that. But we post about this stuff on social media quite a bit. And so, yeah.
Okay, well, there's many, many, many notes of appreciation in the chat. I'll send them to you. I see a clap. I hear a lot of clapping in people's chats also.
Thanks
So,
for
Bryant, thank you so much for your care and attention and your science-based presentation.
Happy to be here. Thank you. All right.
Thanks, everybody.
Brian. Thank you, Bryant, very much. Very interesting. And congratulations on your Instagram post with so many comments. That is really stupendous. Good to stir things up.
You should go read some of those comments. They are.
Yeah, I pulled it up while you're talking. I plan to read them. Yeah, some of them.
They're fun. I spent the first couple of days as it was going viral, I spent a lot of time responding to comments in good faith. And then I realized that there was an entire group of people, an entire portion of the population that was really homing in on that post and had some interesting conspiracy theories and all sorts of stuff. And I realized that responding was not very useful in that situation, but interesting stuff.
Right.
For sure.
Right. Okay. Well, thank you so much for coming, and we'll have our Forest Protection Forum, I think the 4th Monday in February due to holidays. We think it's going to be a speaker on the Northwest Forest Plan, but we haven't got a name yet. So.
And I also do want to be clear that Bryant will be coming again to our Forest Protection Forum to talk about clear cutting in California, and we will advertise that as well.